Which of the following triples of numbers have the same standard deviation as the numbers r, s, and t? So we have some set of numbers r, s, and t, for which we do not know the standard deviation, and yet we need to find another set of numbers that will have the same standard deviation. So what do we know about standard deviation? Standard deviation is the measure of how far on average each of your terms are from the mean. So when will that be true, that we will have two sets with the same standard deviation? So A, you can have literally the same set of numbers will have the same standard deviation, but I don't think that will be an option. Or if I adjust all of my values by the same amount and in the same direction, well then my new set of numbers will still be the same distance apart from each other, and therefore their spread will be the same as what it was before, and their standard deviation should be the same as what it was before, because the mean will also adjust upward by the same amount. Um, so for example, if r plus 2, s plus the easiest way to visualize it's probably just if I came up with, so if I have some set where the standard deviation is 0 because all my numbers are the same. Well, if I then add 2 to every number, my new set is 5, 5, and 5. And so my new terms aren't the same, but my numbers are still 0 apart from each other and 0 apart from the mean. So their standard deviation should stay the same. So here it looks like if we look at our statements, statement 1, so here we just subtract 2 from every number, so that should have the same standard deviation. And so 1 is going to be true, so we can eliminate B, and that's it, I guess. Statement 2 says 0, r minus s, t minus s. So what did they do here? So it looks like they just they subtracted s from every single one of our terms, and s minus s is 0, which is how we got this guy. And so that's sort of the same thing we did in 1, just with a different value. So 2 should also be true, and we can eliminate a and d now. Now what about 3? So 3, our new set is r minus 4, s plus 5, and t minus 1. So I see what they're doing here, I think. So they're trying to get you to think that our adjustments offset each other. In other words, I adjusted this guy down by 4 and this guy up by 5. So net, I have a change of positive 1. And then here I subtract 1 for a net change of 0. And therefore, they're trying to get you to say, okay, that means your new set will have the same standard deviation. But hold on a second. We don't know anything about our values for r, s, and t. We don't know whether r is above the mean or below the mean or equal to the mean. So when we subtract 4 from it, we don't know if we are getting closer to the mean, which would reduce our spread, or if we are getting farther away from our mean, which will increase that spread. So the fact that these numbers here cancel each other out is sort of irrelevant. And therefore, 3 does not have to be true. So our answer is C, 1 and 2 only.